Hello! In this video we are going to preview Quiz 9. Now hopefully you're watching this video on Thursday and the Quiz 9 feedback deadline is Sunday. So you have your class period on Thursday, your class period on Friday, plus you've got Thursday night, Friday night, Saturday night, and Sunday, all of those days to work on this to get it in before the feedback deadline. I strongly encourage you to turn your quizzes in before the feedback deadline if you're not already in the habit of doing that. I've noticed a huge difference between the grades of students who get feedback and students who don't. So especially if you're struggling in class and you need a little bit of a boost, turning this in and getting some feedback will make you much more likely to do well on the quiz by the final deadline. So let's jump into what this quiz looks like and what you are asked to do. The first question is going to ask you to compose a couple of functions, and I'm going to fill in a few typos here. So this should say f of g of -4, and this should say g of f of 3. They just track with this and this. It just wasn't filled in on this form, so you'll need to write those in. But those are the spaces to put your answers. Now, remember, when you're finding f of g, you start with f, and you're going to rewrite everything in f, except you're going to leave big blanks where you're going to plug in g. So you plug g of -4 into these blanks, and that will help you find your f. These should be able to be simplified down to a numerical answer. You won't have any x's left in your response. Now, when you find g of f, it's the opposite. You're going to start with g, you're going to rewrite g, and leave a big blank everywhere there should be an x. And inside that blank, you're going to put f of 3, in fact. And so simplify those down, get your numerical answer. And that's part A. Part B, you can completely ignore. So I was working this out, and the method to finding the domain of these two problems is more complicated than any of the problems you've done in class so far. So I don't know why they're throwing this type of domain question at you right here on a quiz for the first time ever. But don't worry about part B. So all you have to do on number 1 is A. Question 2 is another type of function problem where we're putting f and g together, but this time they're asking you to divide g by f. So I find this notation a little confusing. Another way to write this is g of x over f of x. They mean the exact same thing, and to me this is way more clear. So build your new function out of your g and your f, and then that will go down here. But then they ask you in part B to find the domain. Now, I have a couple of things to say about that. First of all, when you first build your composite function here, it's going to look pretty wild. It's going to have like fractions inside of fractions, and you'll be able to simplify that. And the simplified version is what's going to go in your answer here. So we'll say this is simplified. However, when you're looking at what the domain is, do not look at the simplified version of the composite. Look at the original, we'll say original unsimplified version. That's very, very important. And with domain, pretty much all you're looking for are not letting your denominators be 0 and not letting your roots be negative, but these two functions don't have any roots in them, so really you're just looking at your denominators. Part C is pretty straightforward. It's very similar to question 1. You're going to find g of f and plug in 6, and then you're going to find f of g and plug in 1, and you'll use the same process you used in number 1 for that. And I don't know why these are blank. Fill that in with a 6 and fill this blank in with a 1. Question 3 is a completing the square problem. So we start out with a quadratic equation, and we want to put it in standard form, which requires completing the square. So I'm sure you've got lots of completing the square problems in your notes. Refer back to those if you don't remember the steps for doing this. Once you have it in standard form, you'll write it right here. It's still p of x, so you've got p of x will equal, and then write it in standard form. And once you have it in standard form, your vertex is equal to negative b comma c. So it's really easy to figure out what your vertex is. Remember, concavity, we're talking concave up or concave down. It's going to be one or the other, and it depends on the sign, positive or negative, in your leading coefficient. D asks you whether there's a maximum or a minimum value. Remember, quadratic equations form parabolas. So if you have a concave down parabola, you'll have a max. If you have a concave up parabola, you'll have a min. And they ask what the max or min value is. The value refers to the point right here, and the special name for that point is vertex. So, lo and behold, part D and part B are actually asking you for the same thing. The axis of symmetry would be this line right here. So our axis of symmetry is a vertical line, so it always is in the form of x equals some number, and that number is the x value from your vertex. And what intervals is p increasing? So when we're talking intervals, we're talking interval notation. So we're either talking about something like this, comma this, or you might have parentheses on both sides, brackets, etc. And what we're asking for is where on our graph, what x values on our graph is our function going in an upward direction. Now, upward directions look like this. So looking at the two examples I drew before, I'm going to use red to show you where these two parabolas are increasing. So the left-hand side of a concave down parabola is actually going in an upward direction. If you trace it from left to right, watch, I'm going up with my pencil. But in a concave up parabola, it's the right-hand side that's increasing. As I go from left to right, it goes in the upward direction. Now I'm going to use blue to show you decreasing. The right-hand side of a downward-facing parabola is decreasing. It's going in a downward direction as I go to the right. And then in a concave up parabola, as I trace this from left to right, my pencil's going in a downward direction. So I'll do decreasing in blue, increasing in red. Make sure you write these in interval notation. Interval notation. All right, and then for part G, we're looking for the x-intercepts and the y-intercepts. The x-intercepts are the places where our y values equal 0. So you can find those in any number of ways. We're basically looking for what we call the zeros of the function. So you set the function as a whole equal to 0. And depending on which version of that you use, you're going to solve differently. If you use the general form of the function and set that equal to 0, that's going to be like ax squared plus bx plus c equals 0. Then you're going to use the quadratic formula. If instead you choose to set the standard form equal to 0, instead you'll have what? A x squared plus b, I did that wrong already. It's x plus b squared, plus c. You'll set this equal to 0, and you'll solve this by just isolating x, so getting x by itself on the left. First you'll subtract your c, then you'll divide by a, etc., until you have x by itself. Either way, you'll get the same answer. And remember, you always get two answers because it's like something plus or minus the square root of blah, blah, blah. So you'll get the plus and the minus versions go here and here. All right, for the y-intercept is the easiest of all. For the y-intercept, you almost always want to use the general form because the y-intercept is the place where x equals 0. And so if you notice in the general form, if I plug a 0 in here and a 0 in here, then my y-intercept is just little c. So from the general form, y-intercept's really easy to find. We want to state the domain and range. Domain and range of a parabola is usually very, very easy. Once you know your vertex, you'll know your range almost immediately. So I'm not going to give you much more on this one other than to point out you want to write it in set notation. So you'll have the set of all x values such that, and then you'll need to figure out what that is. Range, remember, is y values, so you'll have the set of all y values such that. All right, and then once you have all of that information, you'll know your intercepts, you'll know your domain and your range, you'll know your vertex. You should be well set to answer part I, where you just draw the parabola with as much detail as you can. Number 4 is a word problem that has to do with the area of a margin. So we've got a page of a book that is rectangular, and they give us the dimensions of the page. So 1829. Then they tell us that the text only takes up a certain portion of it. There's a uniform margin around the outside, and the uniform margin is 1.2 centimeters wide. So this distance is 1.2. And they want you to find the area of the printed text. So this should hopefully be pretty easy. You need to figure out what this length is and what this length is here based on the size of the margin. And once you know those two things, you just take the area of the outside minus the area of the inside, and you should get a number. Don't forget your units. And don't forget with area, your units will be squared, so make sure you have those correct. For part B, they make it a little bit more complicated because instead of giving you a number for the dimensions of the margin, they give you a variable. They say, imagine that the margin is x units, and then we have to set up a formula or a function to represent the area of the margin. So it's still the same. Area of the outside minus area of inside. And so the area of the outside is still just going to be a number based on the dimensions of the outside of the page. But the area of the inside is going to look more like a function because it's going to have x's and variables in it. And we did an example like this in class one day, and I know you've done some of these for homework, so you should have some similar examples in your notes. Question C then requires you to use this function that you built in part B and to plug in this value as your margin width. So you'll plug that in for x into the function that you built for part B, and for your answer in C, you'll just get a numerical value with units. Don't forget to square your units because it's area. Part 5 is another pseudo word problem, and this one requires you to remember a formula. So they're asking you for profit, P of x, and the profit is equal to the revenue minus the cost. That is a formula I've asked you to memorize, but since you have your notes available to you while you're taking this quiz, I see no issue with actually just reminding you of the formula right now. So here for revenue, you're going to plug in this formula or this function. And here for cost, you're going to plug in this function. Now, I cannot stress enough that when you do that, you have to put parentheses around r of x and around c of x. It's going to make a huge difference when it comes to things like this negative sign right in the middle. So your answer for p of x will look like a function. It will have x's, etc. in it, and it's not going to be a super pretty one either. Some of these numbers are pretty big. Parts B and C, they're asking you about maximum. What does a maximum sound like? It should ring a bell. We've been talking a lot about vertex or vertices lately. So these two questions, although they're asking about the same point, they're asking for a different value. Part B is asking for the maximum profit. That's our Y value. And part C is asking for how many bottles will maximize the profit, and bottles were X. So there's also a note here. Remember, X is the number in thousands. So hypothetically, if you end up with the answer X equals 2, then you would write down 2,000 for bottles sold. So just don't forget to make sure you convert your answer into thousands. And I think that's the last problem. Yeah, it is indeed. All right, so this quiz has 5 questions on it. That means you've got wiggle room of 1 question because you've got to get 4 of these right. So your chances of getting at least 4 of them right increase tremendously if you submit your quiz before the feedback deadline. So please do your best to get these in before Sunday at midnight.